Okay, so let's go ahead and start talking about how we can solve inequalities with absolute values. First thing we need to do is get the absolute value by itself. If you notice, this one's greater than, so we should be thinking it's probably going to shoot outwards. So A would be my first initial guess. But let's go ahead and check and make sure. So we need to add 3 to both sides. Then we got 4 times the absolute value of x is greater than 3. Now we need to divide both sides by 4 to get the absolute value completely by itself. So when we do that, we see that the absolute value of x is greater than 3/4. So here we have to split this up and get our two inequalities from this. So our first inequality, we're going to write the left-hand side without the absolute value. We have to flip the inequality and then change the sign of everything else on the right side. And the second inequality, we just remove the absolute values from the left-hand side, keep the inequality the same, and keep the right-hand side exactly the same. So if we want to think about this on the number line, we've got an open circle at -3/4, and then we shade to the left. And then we have an open circle at +3/4, and we shade to the right. You can notice since it was a greater than problem with absolute values, it did shoot outwards. There was a gap in the middle, so the answer is A. Okay, so here's another absolute value inequality. Here we go with this one. It's got the absolute value already by itself. And we see less than, so I'm already thinking that it's probably not C or D because it's got the word or in it, because less thans are and problems. So again, we set our two inequalities up. The first one, we remove the absolute values, flip the inequality, and change the sign of everything on the right. The second one, we keep the same. So we're going to add 2 to both sides. We get 3x is greater than -5. Divide everything by 3. X is greater than -5/3. And that's actually enough to find our answer, but we'll keep working this out to make sure we know how to do the whole problem. So we add 2 to both sides. We get 3x is less than 9. And then we divide everything by 3 and we get x is less than 3. So when you think about the number line, it's got an open circle at -5/3, open circle at 3, and you shade in the middle. So the answer would have to be A. Okay, now if we want to write an inequality, the first thing we need to do is find out where the middle is. And hopefully you see, since this is shaded in the middle and not shooting out, this is a less than problem. It's an and. So notice there's 8 units there. So if we want to think about where that middle is, we know we cut 8 in half and we get 4. So if we go either back 4 units from +3 or forward from -5, we're at -1. If we plugged in -1, what would make it 0? And it would be x plus 1. So we know that B and D are definitely not it. And since it's less than, because it's shaded in the middle, and then we put half the distance, or the amount we can go left or right from -1. So the answer has to be C. Okay, so now with number 4 here, the first thing I'm thinking is that it cannot be C or D because those would be greater than problems, and this is a less than. So we need to write our two inequalities. So the first one, x plus 3 greater than -3/4. And then the second one is just exactly the same without the absolute values as the original, that is. Now we can go through and solve both of these. So subtract 3 from both sides. And if we're thinking about subtracting 3, -3 is actually -12/4. So negative 3/4 minus negative 12/4 is negative 15/4. So that's actually enough again to get our answer, but we'll keep working this out. So again, we subtract 3, and 3/4 minus 12/4 gives us negative 9/4. Remember, you can do these on your calculator and then hit math enter to convert it back to a fraction for you. So the correct answer is A. Again, remember, those would be greater thans, so that's why those would not work. All right, so with this problem, I think the easiest thing to do is just to start off by drawing 3 number lines. And we're going to graph one inequality on one on the other, and then the third one's going to be our solution. We're going to graph where these things overlap at. So the first one's pretty easy. We'll do x less than 2 there. So we'd put an open circle at 2, and we would shade to the left. Now with the x squared greater than 3, we should be thinking, all right, this is going to be one that shoots outward, not shading in the middle because it's greater than. And then basically we can think about the graph if we wanted to. So we would just start off, since this is greater than, we know we'd shoot outward with this quadratic. So the first thing we would do would be we would take the square root of both sides, and we would get x equals positive and negative 3. Or I'm sorry, we would get x equals positive negative square root of 3. Now, since we know it shoots outward, we use the negative square root of 3 as like the left boundary and positive square root of 3 as the right boundary, and we would put open circles on them and shade outward. And then we would look at the two graphs and see where they overlap. So we would have an open circle at 2 and then an open circle at square root of positive 3 and shade in between those 2 points. And then notice the overlap is also at negative square root of 3 shading to the left. So we'd put an open circle at negative square root of 3, and then we would shade to the left. So notice the only one that matches that information is C. Okay, so if we want to solve this system of equations, the best thing we could do is set all of our information up into a matrix, and we will use the row reduced echelon form. This way we can just type it straight into our calculator. Notice if one of the variables is missing, we're using 0 as a placeholder, so all our x's, y's, and z's line up. So now when we put that into our calculator, remember there's a couple different ways you can do it. If you go to math, and then up a few, there's the row reduced echelon. And then you can either save the matrix or use alpha zoom to put it in on the fly here. Okay, so now looking at this, we can see we have a solution, and that the x is 1, the y is negative 2, and the z value is negative 1. So our answer would be B. So when we're solving a system of inequalities, we want to make sure we get everything into slope-intercept form just so it's nice and easy for us to graph. Also, if we look at these multiple choice options, we see that 2 of them can't be a solution because you can't shade above and below a line of an inequality. So C and D neither one of them would be possible solutions. So we will start off by getting the first inequality solved for y. So we can subtract x from both sides, and then we need to divide everything by 2. So we'd have y is less than or equal to negative 1/2 x plus 3. So now to solve the second inequality, we want to start off by subtracting 2x from both sides. And then we'd have negative y is less than negative 2x minus 2. So we need to multiply everything by a negative 1. And remember, we'd have to flip our inequality so it would become y is greater than 2x plus 2. So now, looking at these two inequalities, the solid line with the negative slope that crosses at 3, we would shade on the side you can't walk on. So the answer would have to be B. Okay, so with this one, remember we want to use the idea that we know that ax squared plus bx plus c equals y. So we're going to plug in the x and y values to set up a system of equations of 3 variables to come up with the actual quadratic equation that we're trying to find. So we'll plug in negative 1 for all the x's and then 5 for y. And then we've got a 1 for the x in this one and an 11 for the y. Then the last one we have 3 for x and 1 for y. And if we actually wanted to solve this, we could use row reduced echelon form to get the a, b, and c value very quickly. So now we just need to multiply everything out so we can have our system of equations. So we'll label them here 1, 2, and 3. So equation 1, negative 1 squared is 1, so we just have a minus b plus c equals 5. The second equation would just be a plus b plus c equals 11. The last equation would be 9a plus 3b plus c equals 1. And we can see the correct answer is A. We will discuss this problem in class. Okay, so with this problem, we would set it up just like the previous one, but we actually have to do the row reduced echelon form on it to find the actual quadratic equation that we're looking for. So here we'd have just plug in our x values and our y values. Plugged in 1 for x, 20 for y. Now we'll plug in 2 for x and then 21 for y. And then we will plug in 3 for x and 18 for y. So I'll go ahead and multiply everything out, and we'll have a plus b plus c equals 20. 4a plus 2b plus c equals 21. Then we'd have 9a plus 3b plus c equals 18. And then we can turn to our calculator to use the row reduced echelon form. So this is what our matrix would look like. So in our calculator, we would go and use the row reduced echelon form, and then we would put our matrix in, and then we'll be able to find the a value, the b value, and the c value. So we know our A is -2, our B is 7, and our C is 15. So we can go back and write that in the quadratic. We can go to y equals and just use our table to find out what the y value is when x is -4. I'm sorry, when x is 4. When x is 4, y is 11. So our answer would be B. All right, again, we'll talk about this one in class. All right, so with this one, we just need to kind of draw this picture out. You know, we have a vertical line at 0, a vertical line at -4, and then a horizontal line at 0, and a horizontal line at -6. And that will create a rectangle 4 units by 6 units. So areas length times width, we multiply those together and we get C, 24. Okay, so with this problem, we want to get everything in the slope-intercept form. And then we find the vertices of where all these overlap, and we will plug those values in into that maximizing function and see which one gives us the greatest value. So the first equation we just had to subtract 4x. This one we need to subtract 4x and then divide everything by 3. And I will be using the calculator to kind of graph everything and come up with our ordered pairs that we need. So remember that the triangle on top is greater than and that the triangle on bottom is less than, so the shading is done correctly on the calculator. So we have to keep in mind here that we had x is greater than or equal to 0 and y is greater than or equal to 0. So if we imagine those being shaded, we can see that triangle there in the first quadrant, and we would have 3 vertices. So we can see that we have one at 3, 0, and at 6, 0, where they cross the x-axis. And then just to make sure we can identify that other one, we can use the intersect feature. So we do second calc, intersect, select the first line, second line, and then your guess. So we get out 1.56, so that will be our other ordered pair that we would need to check. And we can also verify where those two cross the x-axis by looking at our table. And you can see they're at 3, 0, the blue line, and then the red line is at 6, 0. So now I'll just use the calculator real quickly, type in the x and y values into our maximizing function and see which one gives us the greatest value. Well, the 1.56 gives us 21, and actually if we look at our options for our answers, that is the biggest number. So we know we found the right answer, but we can go ahead and plug in the other ordered pairs too, just to practice this. So we'd have 2 times 3 plus 0, because the y value is 0, so we just get 6. And then for this one, we would have 2 times 6 plus 0, and we had to get out 12. Okay, so this one's just like the last problem. We want to get everything solved for y so we can easily graph it. So we'd want to subtract x from both sides of that first one, and we'd have y is less than or equal to negative x plus 6. And then on the second one, we would want to subtract x from both sides, and then we would need to multiply everything by a negative 1. So we end up with y is greater than or equal to x minus 6. So again, I'm going to use the same method here and just graph everything on my calculator and let it find the vertices for me. You remember we've got x is greater than 0 and y is greater than 0, so we're in the first quadrant. So again, we can see that triangle there. And we would just need to find the y-intercept and the x-intercept, and we can see that the other ordered pair would be at 0, 0. But that would just produce a value of 0 if we plugged it into the maximizing function, so there's a good chance that that one is not it. So we can find out where we intersect, where we are at 0, 6 on the y-axis, and on the x-axis we're at 6, 0. So now we can plug those in, but again we can verify everything on the calculator through the table if we wanted to. We just plug those order pairs into our maximizing function. So plugging in all those ordered pairs into our maximizing function, we would see that the ordered pair 0, 6 produces the maximum value. So our answer would be B.